Okay, hello everyone, welcome back to the new week. So in the last week, we have provided you with the introduction for the one-pass algorithm already, and we also introduced how to use this one-pass algorithm to implement several or concrete operators in database systems. And this week, we will continue to discuss about the query processing, and we will be focused on the two-pass algorithms and use them to implement some concrete operators again in a different way. In this week, we plan to finish the query processing in this section, so we can move to the query optimization in the next week. So according to the schedule, in this week, we will have the deadline for homework 1 to be due by this Friday. I think right now you should be able to work on most of the questions in the homework 1 already, and we have provided with introduction for the one-pass algorithm as well as the two-pass to be introduced in this week. And so you can finish all the questions in homework 1 by this Friday. And also remember to submit the solutions to the Canvas system in one single PDF document. Also, we just ready the paper 5 to be reviewed in this week, and you can access the paper 5 by clicking this link. So please read this paper and also write a review report of this paper which will be due by next Friday. So besides this, in the next week, we will also have another deadline for the project, stage 4 as well. So it's time for you to work on the project right now, and also according to a schedule, step by step. It will take lots of time to do both experiments as well as writing the final paper report. So please schedule your time in advance so you don't need to rush at the very end. Okay, so this is a plan for this week, and let's move to the two-pass algorithm to be discussed in this week. Okay, I hope you still remember what's the difference between the one-pass algorithm versus two-pass algorithm, right? The main reason we have the one-pass algorithm is because for some data, the size is very small and we can hold the whole data into the memory for the operations. If so, then we can use this one-pass algorithm. However, for some cases, if the memory is very small or the data we have is very large, it's impossible to load the whole data into the memory. Then we need to use a two-pass, even a multi-pass algorithm instead, right? So here we will be focused on the two-pass algorithms, and we are focused on studying the relations which are larger than what the one-pass algorithm can handle. The basic idea of the two-pass algorithm is to use two passes to scan the data we have for processing. For the pass 1, normally we need to organize the data properly into some groups or sub-relations instead. In other words, we read data from the disk and also do some operations to organize the data into some subgroups, and also write them back to the disk again. With this step, we can do some basic operations like sorting, indexing, right? And it will be helpful for the following steps. In the pass 2, we will reread such sub-relations and also do some operations for achieve the target of the operation, right? So you can see the basic idea for the pass 1 is to do some pre-processing and also write back to the disk. For pass 2, we read the pre-processed data and then do the operations. Next, we will use one concrete example to show you how to study and how to use this two-pass algorithm to do some operators in database systems. The example we are studying here is to do the merge sort. I hope you still remember the merge sort, right? So for the merge sort is given two arrays, and these two arrays are sorted already. The target of this merge sort is to merge these two arrays into a sorted list of numbers. And in this page, we show you with the example. Let's assume we have two arrays, array 1 and array 2. For array 1, we have four numbers, 1, 4, 6, 7. For array 2, we have 3, 5, 8, and 9. You can see both array 1 and array 2, they are sorted already. 1, 4, 6, 7, 3, 5, 8, and 9, they are all sorted, right? And the target here we are studying for the merge sort is to merge these two arrays into a sorted list covering all the numbers in these two arrays. We want to merge them together. So the basic idea for the merge sort is to scan the two arrays according to the positions, right? Now, starting from the head of the arrays, we'll compare the numbers to decide which one to output, right? Normally, we want to output the small size or small numbers into the output array instead. And then we can move the pointer to the next position for the one we have outputted. Let's see this example. We have 1, 4, 6, 7 here, 3, 5, 8, 9 here, and we can compare the first position of these two arrays, right? For the array 1, the first position number is 1, and for array 2, the first number is 3. We'll compare them with each other. We see 1 is less than 3, so therefore we can output 1, right, to the output list. So 1 we have here as output. And then next, we can move the pointer to the next position because we have output 1 already. Then the head of the array 1 will be 4 instead. And we can further compare this 3 with 4, right? We see that 3 is less than 4, so we can output this 3 from array 2 to the output. and we can move the pointer to the next position, and we can further compare 4 versus 5, and we can output 4, right, as output. And next we can further to output 5 and 6, 7, 8, and 9, right. In this way, we can generate the output via the merge sort. We can see from output, all the numbers in this output will be sorted again, right? 1, 3, 4, 5, 6, 7, 8, and 9, right? So they are sorted. So this is a general idea for the merge sort algorithm we have studied before. And here we want to study the merge sort in database system. How can we merge two database system or two table relations into a sorted relation instead? So which will be the target in this part. And we will use this two-part algorithm to implement this merge sort algorithm for you instead.